Alright guys, welcome back. I want to do this short video on the support for 9.6. A lot of this we've seen. I just kind of wanted to review a few pieces. So that you'll, kind of be up to speed. So we're just going to briefly review rational equations. So these are equations that basically have fractions in them, essentially. And so our goal is to try to eliminate those fractions, and then it makes those equations much easier to solve. And the way we actually eliminate those fractions is multiplying both sides of the equation, or every term, if you will, by whatever the least common denominator is. So in this case, with this first example, these two denominators, guys, are completely distinct. You have a binomial here, y plus 2, and another denominator that's just 3. So in a lot of these types of problems, your least common denominator is going to be a combination of those. It's going to be 3 times y plus 2. So if we multiply both sides of this equation by 3 times y plus 2, those old denominators are going to divide out, and we won't have any fractions anymore. And so that's what I'm going to proceed to do. So I like to keep each side in parentheses and multiply by the LCD. And then the right-hand side, 2/3, multiply it by the same thing. And so what we see happen right here on the left is this factor of y plus 2 is understood to be in the numerator, and this one's in the denominator, so those are going to divide out. So you can cross those out. And then what you're left doing is distributing this 3. And so 3 times y will give us 3y, and 3 times -6 will give us -18. And now on the right-hand side, these 3's will divide out. And we're going to end up distributing this 2. 2 times y is 2y, and 2 times 2 is 4. So now we've got an equation, just a one-dimensional equation. Okay, and remember, we want to get the y by itself, so I'm going to subtract 2y from both sides. So 2y minus 2y is 0, so that's going to leave me with 4 equals 3y minus 2y is just y, and that's be left with a -18. And then from here, guys, to isolate for y, we need to add 18 to both sides. So we're going to get that y is equal to 22. Okay. Now these technically you need to check, because if your solution causes the denominator in this original equation to become 0, then you have to discard that solution. But in this case, guys, we're okay, because if I plug 22 in for y, this denominator will become 24. So as long as it's not 0, we're good. So this means that 22 is going to be our solution for that particular equation. And it does, in this box, it does say check. Okay, and it mentions that you don't want to make the denominator 0. So if you have ever had a solution that did that, then you're going to have to throw it out. All right, let's look at another one, very similar. This is example 2. Okay, so here, these denominators are both distinct as well, and so you'll see that a lot in this chapter. You've got a binomial, and then over here you've got a monomial. So the LCD is just going to be a combination of those two. The 4x minus 3 times, actually I'm going to put the 9x in front, just because that's more customary since it's the monomial. The 9x in front, and then the 4x minus 3. The binomial is the second factor. So we'll do it the same way we did the last one. We're going to multiply both sides by oops, by that same LCD. And so we should see some stuff divide out again. So the 4x minus 3's on the left-hand side, that's going to leave us multiplying a 9x times a 7, which is a 63x. And on the right-hand side, the 9x's will divide out, and that's going to actually leave us distributing this 4 to both of those terms. So 4 times 4x will be 16x. And 4 times that negative 3 is negative 12. And then, guys, we'll just finish it out from here. Let's try to get our x's on the left. So I'm going to subtract 16x. So we're going to be left with negative 12 is equal to, I believe that's going to be 47x. And then we need to divide both sides by 47. So we're going to get x is equal to negative 12/47. Now this is a fraction, so you want to try to simplify it if you can. But guys, this one is irreducible. 12 and 47 have no common factors. And then again, you know, you would want to check, but if I plug this negative fraction in here for this x and multiply it by 9, it's not going to become 0. And if I plug this negative 12/47 in for this x, multiply it by 4, and then subtract 3, I can kind of see in my mind, you may need to use a calculator to verify, but that denominator would not become 0 either. Okay, so therefore, we are good on this one. Negative 12/47 is the solution. So just be aware that technically you are supposed to check these solutions. I usually just sort of check them in my head. Alright, and the last thing I wanted us to look at is just a bit more practice on solving these quadratic equations. So this one's quadratic because it's got an n squared in it. And it's already in standard form as well, that ax squared plus bx plus c, except we have n playing the role of x in this case. Alright, now with one like this, guys, and that's why I put this in the notes, you're going to have to factor it using what we call the AC method. Okay, so this is one you may be kind of rusty on. You literally take well, first let me write the quadratic equation in standard form, because A, B, and C just refer to the coefficients or the numbers that are in this trinomial here. So you can see that A is 2 and C is negative 18. So the AC method dictates that we multiply A and C. So 2 times negative 18. Move myself over. That is negative 36. And then we need to find factors of negative 36 that when summed together will give you 5. We can guess and check with your calculator, but I think it's going to be 9 and negative 4. Okay? And so what you do at this point is a technique that we call factor by grouping. Okay, because what we do is we rewrite or rename the middle term. Instead of writing 5n, we write 9n minus 4n, because this is still 9n minus 4n is still 5n. And then we bring down the first term and the last term. And it's called factor by grouping because we group these up in parentheses. First two terms, you're going to put a plus sign to make sure that negative goes inside the second set of parentheses. And then what we do is we try to factor out what we refer to as the greatest common factor from each of these groups. So these first two terms here, they only have an n in common. So if I take out an n, you can go back and divide to see what you'll have left. You're going to have a 2, and n squared divided by n is just n. In your second term here, your n's will divide out, and that's just going to leave you with a plus 9. But guys, in the last group here, these two terms, they have a 2 in common, but you don't want to take out a 2, you want to take out a negative 2, because whatever we're left with in parentheses, we want those to be consistent. So I'll take out a negative 2 as my GCF. And so when I do this, negative 4 divided by negative 2 is actually positive 2. So this leaves me with positive 2n, so that matches what I already have. And negative 18 over negative 2 is a positive 9. So now we've got a common factor of 2n plus 9 in both of those terms. So then we factor that out. That essentially becomes our new GCF. And we plug in this second set of parentheses, whatever's left over. So in this case, it's going to be an n and a minus 2. Okay. And so this is the AC method that involves factor by grouping. So I've got it factored. My last step with these quadratic equations, if you can factor them, you could also have solved this using the quadratic formula. That would work equally as well. But if I'm factoring, my last step is to take these factors and equate them to 0. Okay, so this one you can just sort of look at it and see that n's going to have to be 2. But here you may need to subtract 9 from both sides, and then divide by 2. And we're going to get that n is equal to negative 9 halves. Okay? So those are the two zeros of that quadratic function, or the two solutions to this quadratic equation. Okay, so this is just a little bit more review, just to kind of keep you fresh on some of this material.